Hi guys, welcome to my YouTube channel Tech Hub World. Today we will see about time and space complexity and what are the contents here it is mentioned. First is time complexity and second is Big notation, third is space complexity. Then we will see various algorithms, time complexity and space complexity, and in the last we will see one example. Now what is time complexity? Time complexity is the measure of time taken by an algorithm to run. We represent time complexity in three ways, like base time complexity, average time complexity, and worst time complexity. For practical purposes, we will go with the worst case time complexity. In other words, what is the maximum time an algorithm can take to execute for a given size of an input. Then we represent time complexity by big O notation, and next one is if an algorithm is taking same amount of time for every set of inputs, then it is time complexity will be big O of 1. If time complexity increases linearly with the size of the input, such a complexity is represented by big O of n. And how the time complexity graph will look like if it is time and if it is input, then how it will change with respect to input. If it is linear, then graph will be like this. If it is n square, then it will be like this. And next one is space complexity. Now before that we will see how to calculate time complexity. First we will sum up the total time for all the operations, then we will drop the constants, then we will drop the non-dominant terms. We will see it in the last. Space complexity. Space complexity is the measure of amount of memory or space an algorithm uses. Algorithms that use constant extra space, that is O of 1, are called in-place algorithms. M for low space complexity. We always aim for low space complexity. And some common space complexity are big O of 1, means it is a constant space. Means with respect to input, the space will not change. And the example is swapping of two variables. Then it is big O of n, meaning linear space. When we use array like copy of an array, then it is a big O of n space complexity. And a next one is big O of log n, and we call it logarithmic space, and it is often used in binary search. And then next one is big O of n square, and it is a quadratic space, and we use it in like example for this is 2D matrix for dynamic programming. Next, this one is some common values and their implications. If it is big O of 1, means it is a excellent time complexity, and if it is big O of log n, then it is good. If it is big O of n, then it is average. If it is big O of n into log n, then it is bad. And if it is big O of n square, then it is very bad. If it is big O of 2k power n, then it is very very bad. And if it is big O of n factorial, then it is very 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 bad. Means it is the worst case time complexity if you see. And next, this one is the example of how to calculate the time complexity. If you see here, we have created one object of a scanner, and it will just take 1 unit of time, means it is big O of 1. And here it depends on user. Then this one, like for this, if we sum, then 3 times of big O of 1 it will come. And we remove the constant terms. If you see in the first second line, like drop the constant, then it will be big O of 1. Then sum of first two numbers, it will also take big O of 1. If we add this, then also it will come 2 times of big O of 1. Then we drop the constant, then big O of 1 it will be for this these lines. Here if we come for this for loop, then it will iterate to n numbers. N times it will iterate, means it has time complexity of n. Then we represent as big O of n. Now if we come here, for every 1 unit of j, we will iterate to n times. If you see here again for k, then for 1 we are iterating n times. For second input, we will also iterate n times. Means its time complexity is n times of n. Then we represent it as a big O of n times of n. Then we will add this thing, this time complexity of every steps. If you see, the first step is this one, sum of the total time for all operations, and third one, if you see, drop the non-dominant terms, means what will be coming at the end. From that we will remove the non-dominant term. Here if you see, highest power is n square, means it will dominate. Then non-dominant terms is O of n and big O of n and big O of 1. Then we will remove these two terms, big O of 1 and big O of n. Then it will be become big O of n square. And here we have just used variables and for loop. We have not used array. That's why space complexity will be big O of 1. And if you want to ask like where will we see time complexity as big O of log n, then where we are dividing each steps as a half. In each step we are dividing the algorithm as half. Then it will become log of n, big O of log of n. And we see it in binary search, binary operations. That's it for today. Thank you guys for watching this video. We will meet in next week.